Maybe
All right.
I can kick off.
Yes.
Greetings, everyone, and thank you so much for joining in on time. I do apologize for the background noise, as I've mentioned to those who were here earlier that our Wi-Fi internet is down, so I'm currently joining from Starbucks. I'm hoping that you can hear me. I'll keep it very short. My name is and I'm the founder of Africa. And today we're here to kick off the very first AI class with our amazing experts, Crystal and Professor Anthony. I'm very, very excited for this session. And as I mentioned to you, Crystal, in our call yesterday, we have over 40 women who have registered for this session. And these are all young women that are coming in from the likes of your Kenya. We've got ladies that are coming in from Nigeria, South Africa. And I've also seen in the chat, we've got somebody from Texas also, which is quite exciting. Again, the vision for us for these AI classes is to be able to enable young women with additional skill sets that will put them at the forefront of the tech transformation. One of the biggest questions that I'm usually asked is, people can just go online and learn these things. Why do we have these workshops? And one of the key things that we have been able to identify through these workshops is that, one, it's the mentorship element that they're able to receive from these sessions, but also being able to have opportunities to be taught by individuals like yourselves, Professor Anthony and Crystal, people who have the experience, who are able to not only share on their journeys, but also individuals who are obviously able to make these learnings much more practical and easy for individuals who may have no background or little background. Majority of the community that we have here today is individuals who have IT background, and these are individuals who sometimes, have either been working in the IT industry for quite some time and have not really taken the time to learn an additional skill set. So I'm very, very much excited, and I am hoping that as the session goes on, we'll have more females that are joining into the session. But I'm very excited to have you guys. Thank you so much again, Professor Anthony and to Crystal for making the time. I know due to daytime saving, you've had to move things around today to accommodate our session. We thank you so much for your shared experience and your time here with us today.
Absolutely. Thank you very much for having us. It is very exciting for us to be here and to share with the diaspora, with the African motherland. As a Pan-African myself, I was born and raised in France. My parents are from Congo DRC. I am now based in the Silicon Valley. And in everything that I do, I always think about how Africa is going to benefit, how Africa is going to participate in the fourth industrial revolution. And just to give you some background on why I believe is important for Africa, and we need to upskill and reskill professional women in the field to make sure that we all participate and contribute to what is happening in the world today. So AI technology is set to boom into a 90 billion industry by 2025. And to add, according to PwC, 15.7 trillion. I'm not talking in million. I'm not talking in billion. I'm talking in trillion dollars to the global gross domestic product, GDP, by 2030. AI is everywhere, including in Africa. However, when you look at the distribution of the wealth and power afforded by AI technologies, it has been to date widely unequal. PwC actually estimates that nearly 70% of AI's economic impact will be concentrated in China and in North America. So to avoid for Africa to be left behind, countries in Africa must take advantage of AI technologies to advance local social-economic growth and upskill and reskill its growing and dynamic youth to adapt to new forms of digital work and entrepreneurship. There needs to be, and that's the reason why we are here with Codrs, because there needs to be a particular focus on African women who occupy most positions on low-skilled labor and repetitive tasks in Africa, and can thus be highly impacted by the job losses and the job replacements, which are going to happen, which are already happening through AI automation. So today, as you say in Bali, knowledge is accessible everywhere. Knowledge is accessible everywhere. And it is our responsibility to take advantage of online classes, as we are going to offer through this program, virtual libraries, ebooks, audiobooks, podcasts, to access the knowledge we need to participate in the fourth industrial revolution. And not only as consumers, because we know how to consume of technologies, but those technologies being built in the Western world might not be fully applicable and adapted for our specific needs for African people in the continent, in the diaspora. So when Western world, with the Western world, we are usually providers of those AI technologies or technologies in general through our mineral resources. But we need to participate and contribute as machine learning engineers, data scientists. We need to build and create our own AI technologies for us and by us for our own use cases in agricultural planning, healthcare, education, financial services, mining, environment preservation, and so on and so on. We also need to think about creating our own systems of governance based on our own set of values and our own set of ethics through African policymakers to guarantee the preservation of human rights and democracies in Africa. So it is our utmost pleasure for Professor Anthony Ross, Senior Data Scientist at Stanford University School of Medicine, and myself, Christelle Mamboziga, Responsible AI Committee Member at Cisco Systems, to give you access through the Pink Codrs program to free introductory classes to become AI experts. Within those classes, we will review Introduction to Machine Learning, AI for Understanding Images, AI for Understanding Languages, Generative AI, which is the biggest hype at the moment, and obviously responsible AI, how to continue to innovate in a responsible, ethical manner, which is going to be to our benefits for African people in Africa and in the diaspora. And the learning doesn't stop here. I'm from Cisco Systems. This is where I work in the technology industry, where I have been for the past 10 years. We offer also free online classes and in-person classes through our Cisco Networking Academy. And I will share more information about that. Actually, let me move to the next slide. So we will be offering through our Cisco, we are offering already through our Cisco Academy, free classes on data sciences, which will give you also access to certification. So we will also share additional resources for you to continue the learning and the journey into the next class for you to get ready for the next classes for the next month. With that, Professor Anthony Ross, you are more than welcome to start. Thank you very much.
Okay, let me see if I can share here my screen. Okay, let's see. You see my screen okay, Christelle? Can you see it?
Yes, I can see it. Thank you.
Okay, so let me just a second, guys. Let me. So we're going to chat a little bit about machine learning, you guys. I'm so glad you guys are here. My background was originally in physiology. I'm at Stanford University. My background was originally in physiology, and really mid-career, I returned to graduate school to get a graduate degree in computer science, which I absolutely love, you guys. I'm so glad you guys are here. It's the center of the universe. It's I can't think of a better way to add value to the things that you do, having data skills. So I'm excited to share some things with you guys here. Give me just a second here. I want to keep my eye on the chat here. So if anyone has questions, I'll try to save a little time at the end also. But if you have a question, feel free to put it in the chat, or even if you want to mute yourselves. So let's see here. So most of what I do now is in biomedical data science, most of the work that I do now. But what I want for you guys to get some intuition about machine learning, I know some may be newer learners. So I just want to chat with you, just orient you guys a little bit to this machine learning thing to set up when we talk about artificial intelligence, give you guys some context here. So first of all, when we talk about AI, here's what I want you guys to get, because these are the questions that people oftentimes ask. So you can be what I consider conversant. What I mean by conversant, if you're at a meetup or at a conference or in a conversation with the data team that you know some of these different things. I think it's just imperative, especially if you're a technical person. So when we think about artificial intelligence, you guys, we think about machines exhibiting behavior that we associate with humans, learning, perception, thinking. Oftentimes I think that if it can't do what I can do, then it's not AI. That's oftentimes the measuring stick. It has to be able to replace me. And so here's what I want you to see. When we talk about AI, you guys, this circle right here, here's really what I want you to understand. This whole circle right here is all of artificial intelligence. Okay, whatever you understand it to be. So this is all of AI, and machine learning is a type of artificial intelligence. Okay, because a lot of people ask, what's the difference between AI, machine learning, and deep learning? I really want you to at least get that much. Okay, because it's such a thing. Okay, as Christel was saying, you guys, the world is forever changed. If you're not familiar with some of these language models with ChatGPT and DALL-E, all these types of things, you will be shortly. The world is forever changed now since I think ChatGPT came out in November of last year. And so it's a different world. So these things are imperative technologies. So machine learning is a type of AI. There's other areas like robotics and things like that, but machine learning is a type of artificial intelligence. And then deep learning is a type of machine learning. It's a subfield of machine learning. Deep learning refers exclusively to the use of neural networks, which we'll talk about next time, and unstructured data, data that doesn't fit in rows and columns, like images and video and music and text and tweets. All of that is the world of deep learning. And deep learning is probably what's most associated with AI when you think about deep learning. Deep learning, I think of being human perception, being able to see, computer vision, language understanding. That's deep. That's the world of deep learning. We're going to focus on machine learning proper. Deep learning is a subfield of machine learning, but we're going to focus on machine learning with structured data. I think it's a little bit easier to understand if we're talking about structured data than talking about unstructured data. Okay, so let's talk about machine learning. Let's look at what we did, you guys, before we had machine learning, so you can get some sense of machine learning and kind of demystify. Remember, my goal is just for you to get some intuition about this. It's not going to be mathy or anything like that. I really want you to understand it and kind of demystify kind of your role here. So let me give you an example. Before we had machine learning, you guys, anything we did, you had to code it. You have to tell the machine what to do. So for example, if you wanted to, let's say a person wants to know what their max heart rate is based on their age, okay? If a person got on a treadmill and exercised to exhaustion, what would be their maximum heart rate? Let's say a person wants to know that. Well, you're going to tell the machine, hey, machine, you just want to create a little utility. You might say, hey, machine, I'm going to give you an input. You need to give me an output. You give the machine age. Remember, the machine doesn't have a clue. Machine doesn't live in our world. Machine doesn't know anything about our world. You're going to say, machine, I know you don't know what age is. It's just this number. And here's what you're going to have to do. You're going to have to tell the machine the relationship. She doesn't know anything about max heart rate or age, or what a heart is or anything. So you're going to have to tell the machine what that is. And so you might say, machine, here's what I want you to do. Take the number 220, subtract this number from it, put it into this variable, and return that variable to the user. That's an estimate of a person's max heart rate. And the machine will faithfully do that, but it's dependent on you to do that. Give you another example. Let's say that a person goes to their doctor or to the gym and they get their BMI. And they want to interpret, what does this number mean? What is this BMI? Is this good? Is it bad? What does my number mean? For body mass index. And so the same thing, I say, machine, I'm going to give you an input. You need to give me an output. And that input is going to be BMI. Machine doesn't know what BMI is. You know what BMI is, but the machine doesn't. So sometimes it's rules that you have to tell the machine. So you might say, machine, I know you don't know what this number is, but here's what I want you to do. If this number is smaller than 18.5, put underweight into the variable status. Otherwise, if it's smaller than 25, put healthy into status. Otherwise, put overweight into status and return status to the user. And the machine will do that, but the machine is limited by your intelligence. The machine can only do what we code it to do. That's what we did forever. And so the problem with that are things like this. What rules would you write to tell the machine that a person from a chest scan, this is a normal chest scan, maybe someone who has COVID or pneumonia. What rules would you write to tell a machine to do this? Or even better yet, this is a classic example. How do you tell the difference between a cat and a dog? I just think that's amazing. I don't know. I know it when I see it, but I don't know how to tell a machine that. A 2-year-old can do it, but how do we do it? And a lot of people will look at rules like, well, the cat's whiskers, a dog has whiskers too. A cat may have more prominent whiskers, but a dog also has whiskers, or maybe the cleft in the mouth, the eyes. I think of the erect ears on a cat. A dog has floppy ears, so you could kind of base it on that. But the problem with that, what if the cat has floppy ears? Then your code breaks, and software will always be right. Or what happens if you don't even see the ears? Then what do? We just can't code some problems. Some cats and dogs, you guys, can be very big and fluffy, like this. Or some cats and dogs can be very small, not have any hair at all. So these are difficult things for us to code. Most of the things that are interesting to us today, we can't code them. So let me give you an example. Let's say that you figured it out. Let's say you think you got it. You said, you know what? I stayed up all last night. I think I figured it out. I think I know how to tell the difference between a cat and a dog. Let's say you could. So you're going to give this to the machine. You're going to say, machine, I think I got it. So here's what I want you to do. You might tell the machine some rules like we did. You might say, hey, machine, if this thing is true, and this is true, and this is true, and this is true, it's a cat. Otherwise, it's a dog. And if we could do that, the machine will say, oh, okay, so this is a cat and this is a dog. But as I said, we know that hand-coded rules don't work. There are too many exceptions. This is what I think is wild, you guys. Think about this. How can only your face unlock your phone? I think that's crazy. What rules would you write to differentiate your face from the billions of other faces on the planet? That's crazy. But that's why we have machine learning. Machines have to learn certain problems. We can't code them. We can't tell the machine most of the things that are interesting to us today. Let me give you an example here. I know you guys are smart. I'm gonna give you guys some numbers here. Just think about this. You can put in the chat if you want. If not, I'll tell you the answer anyway. But just think about this. Here you have some numbers. You have 144, 181, 200, 317, and 800. Okay? And this is the associated output. 256, 219, 283, negative 400. See if you can say, what's the relationship there? Can you see it? Or what we say in machine learning, what's the function? Can you see it? If I were to give you a number here, could you tell me what the associated output would be? So just think to yourself, if you can put in the chat if you want, if not, just think to yourselves, can you see the solution there? If not, I'll give you about another 10 seconds. If you can see it, the solution is this, 400 minus the input. And the reason I share that with you guys, here's one thing I want you to take with you. That's how machines learn. Whatever your brain was doing, that's how machines learn. Machines say, you give me the input, you give me the output, and get out of my way and you let me learn the relationship, because you can't code these interesting problems. And the way the machine learns the relationship are with these algorithms, these beautiful algorithms that have nothing to do with you, these beautiful algorithms that are written. These are some algorithms. Next time we'll talk about deep learning algorithms. They're just some algorithms that have nothing to do with you. Machine learning is not you. Okay? So it's this algorithm that sits in between your examples, and it will learn the relationship. And once it does that, we call that a model. Machine say, oh, I can see it as 400 minus the input. That's the solution to the problem. Now, normally it's a black box. We can't see inside what it's learning, but here you can see that's what the machine will learn from your examples. And then we call that a machine learning model. And what happens, you're going to give it some input, and it's just incredible the output that it gives. You say, you know what? I would never pick that movie for myself. It's interesting how it knew that I would like that movie. I would never picked it for myself. I never think I'd like that artist, but I really like that music. Whatever it is, that's what this thing does. It learns whatever we train it to do and give us some input, and just incredibly gives us the output. It says, yep, I'm going to unlock your phone, or whatever it is. That's what machine learning is. We can't code these problems. Okay, so the first take home I want you guys to understand is this. The whole of machine learning is to learn some unknown function. That's all we're doing. It's not you. Your job is not to learn the function. The machine will learn it. But the machine says, you give me X, and I will give you Y. X can be age. You give me your age, someone's gender, their race, and their weight, and I'll tell you if they have diabetes. Or you give me a bunch of pixels in an image, which are just numbers. We'll talk about that next time. And I'll determine whether to unlock your phone. Or you give me a bunch of words in a tweet, and I'll tell you the sentiment. Is the person angry? Is the person delighted? Whatever. That's what the machine does. The whole of machine learning is to learn some unknown function. Machine says, you give me X. You tell me about your world, and I'm going to give you the answer. So we say it models the relationship between the input and the output, or it models the relationship between X and Y. Okay, keep that in mind. That's what's commonly used in machine learning, especially if you're coding. You see X is the machine's knowledge of the world. I is the prediction the machine's going to make about whatever question we asked it. Okay, so let's go back to our cat problem. The machine says, you absolutely can't tell me what a cat or a dog looks like. You can't. It's too complex. You can't. Your job is to give me as many examples as you can. And you're going to find that is your role. Collect as many examples as you can of your problem. And importantly, you give the machine an answer key. Give the machine a solution. And the machine's going to learn the relationship. You just get out of the machine's way. So the machine can look at your solution and say, oh, so this is a cat. Oh, and this is a cat. Oh, and this dark thing down here, this is a cat. Oh, okay. And it's going to say, oh, so this is a dog. And this is a dog. They have floppy ears. And this thing right here, this dark thing, this is a dog. Okay. The machine's got to learn it. You can't code it. The machine's just gonna have to learn it from these beautiful algorithms that we have. And once it does that, you guys, we call that a model. And the model holds all the information about the relationship between the input and the output. It's a thing. It's what we deploy. That's what you put on a thumb drive, or you put on your mobile device, or you put on a server. That's what we use whenever someone's looking for fraud or recommending something to you, or whether it's music or a movie or clothes or a restaurant, whatever it is, that's what this thing is. Okay, so now we take this model, and the model will say, go out anywhere on the internet and find me a cat or a dog. That's what I do. I don't know anything else. I only know cats and dogs because that's what you trained it. And you'll give it some image. It's never seen this image before. But if you trained it, what's oh, definitely a dog. And the thing about this model, you guys, it should do one thing excellently. Just one thing, not a lot of things, just one thing. Can't give you directions, can't recommend a restaurant, can't do anything like that, but it should be able to tell you whether something's a cat or a dog or whatever problem you've trained it to solve for you. Okay, now let's look at structured data. This is structured data, just to be clear. Structured data is probably what you guys are more familiar with. Data that's in rows and columns like this. Now, let's say for this data set right here, we're trying to predict, let's say you want to return to school for graduate school, and we want to predict whether someone will get accepted into their program that they want to get into. Okay? And so here we have maybe some test for graduate school acceptance, what we call a GRE in the United States, graduate records exam, maybe your grade point average, the quality of the university that you're applying from, your undergraduate university, test of English as a foreign language, if that's what you have to take, statement of purpose, you know, what you wrote, why you want to go to the school, how are you going to change the world, whatever it is, this is your statement of purpose, letter of recommendation, hopefully someone has written a letter of recommendation from you, have you done research or not, and then lastly, you guys, this is what you have to get about machine learning. You might ask the university, have you kept a record of those you've accepted and those you haven't accepted? Do you have a record of that? Oh, that's what I need. This is what you need right here. That's what we call the target variable. That's the answer key. That's how the machine's going to learn. That's the first thing you want to try to get. That's what I need. That's what the machine, you give me examples of the yeses, you give me examples of the nos. That's what I'm going to learn from. Everything else we call features. That's the machine's knowledge of the world. This is all the machine knows about the world, is what you tell it here. That's it. If there's something else the machine needs to know, you better tell it. Okay? The machine says, you give me X, you give me these, I'm going to tell you why. Okay? Now the machine says, once we've done this, the machine says, you know what? I don't understand your world. I don't live in your world. I don't understand any of this. I don't read. That's for human eyes. When you're done solving the problem, you just give me the numbers. That's what the machine sees. The machine's going to say, you put the features into X, you put the target into Y, and the machine says, oh, that's what I want. I want some examples of yeses and nos, and let the machine learn this. And it's the same next time, guys, in AI, we talk about images and language. They're all just numbers with an answer key. This could easily be an image to a machine. You'll see that next time. This could be a bunch of sentences to a machine. They're all numbers to the machine with an answer key, and that's how the machine's going to learn. So here's your take home. Instead of programming a computer, you give a computer example and it learns what you want. Okay, so understand that about machine learning. Okay, that's the main thing. Machine learning is not you. Okay, your job is to tell the machine about the world. Now, when I try to learn something, guys, here's what's helped me so much. When I try to learn something, I always have to have a mental model of it. That allows me to lock it down. So in my head, this is how I think of machine learning. You can remember it how you want. Here's what I see in my head. There's this term called pareidolia. I don't know if you're familiar with pareidolia, but pareidolia as humans, biologically, we see patterns. I don't know why that is, but we see patterns. For example, if you were to see something like this, there's nothing there. There's just clouds in the sky, but you might see a heart. A baby can recognize mother's face from birth. It's amazing biologically what we do, and it serves a purpose for us. It's the same thing here. You may cut up in a piece of fruit and you might see something, or something like this. And this is how I envision machines learning. Trying to see patterns in your data. The machine says, give me as many examples as you can until I can see it. Then the machine will say, oh, now I totally see the kind of music you like. I totally get it. You know, come Monday, I'm going to recommend 30 songs. I think you're going to love all of them. That's what the machine's trying to do. Okay, remember the machine can see 1 billion rows, all of them. Machine can see all of them. You can't do that. There's things you can't do that the machine can do. And the only reason the machine needs you is because you live in the world. It's the only reason the machine needs you. Tell me about your world and get out of my way. Okay? And this is how I envision machine learning. It's almost never the machine's fault. if it's not doing well. We just haven't told it enough about the world, given enough data till it can see it. Now the machines that totally see it, totally get the kind of clothes that you might buy, or the kind of vacation you might like, or food that you eat, or whatever it might be. That's how I envision machine learning, is this pareidolia where we look for patterns, the machine's trying to do the same thing. Can I see the pattern in your data? Okay. A few other things as we go down the line here, the types of machine learning I want you to be familiar with. There's two terms, supervised and unsupervised. Almost always supervised is better. Not always. When we talk about generative AI, you're going to see where unsupervised has a really unique position for some of these generative models that we have today. But supervised and unsupervised, at least want you to be conversant about these two terms. Here we have the data set. Let's say this is a playlist for music. Okay. Hopefully you're getting the rhythm of structured data. These are features, the machine's knowledge of the world. The machine says, oh, okay, so you're going to give me song, you're going to give me artist, you're going to give me genre, and you want me to tell you whether you like the song or not. Okay, got it. That's the machine. Now, if there's something else that the machine should know, then you need to tell it. You didn't tell it gender, so cat doesn't know gender. If there's something else that is important about the word, you need to tell it. Otherwise, the machine's going to say, okay, based on this, I'm going to tell you whether you like it, if that's what you want me to do, but you need to give me an answer key. And that's what the machine's looking for, like Netflix or some movie service. Oh, you didn't finish watching that movie. Oh, you must not have liked it. You never went back to watch it. Or, oh, you skipped that song in the first 10 to 15 seconds. Or if you're on TikTok, are you scrolling? Are you lingering on something? Are you replaying and looping it over and over? All of that is feedback to the machine. The machine says, tell me what you're into. Give me feedback, knowledge of results so I can learn. Every model is customized, what we call bespoke. Every model. There's no such thing as a good song or an attractive person or a good dish. It's only what's good to you or attractive to you or a song that you would like. That's all. Every model's trying to learn you uniquely. And so that's what we want. We want this is what we call supervised learning. Supervise my learning, like your professor in college, grading your test and giving you feedback. That's what we're doing here. Nope, didn't like that song, machine. Nope, you're off on that one. Okay, I love that one. It's feedback. That's how the machine's going to learn. Okay, so supervised learning is where you have an answer key. You've told me what you like or whatever it is, who has diabetes and who doesn't, whatever it is, who got accepted into graduate school, who didn't. And then unsupervised is I have a bunch of data, but I don't know, I don't have any answer key. It's what we call the cold start problem. When you first join a service, like Netflix or Spotify or whatever it might be, I don't know anything about you. I don't know what to recommend to you. That's unsupervised learning. And so with unsupervised learning, we can only cluster based on some similarity of features. I don't know enough about you. If I knew your gender and age, maybe I could recommend a genre, but that's not nearly as good if you just told me what you liked. Or if I knew when you were born, I can maybe recommend some songs based on a decade, but it's not nearly as good if you gave me feedback and told me what you liked. So that's supervised versus unsupervised. So quickly, when we talk about supervised, we have what we call regression and classification problems. That's not crucial. And then unsupervised, we tend to call clustering problems. But we're going to talk a lot about this when we get to generative AI. This is really what's made ChatGPT and those models so good. And we'll talk about why unsupervised learning was so valuable for those language models that we are fascinated by today. Now, another thing I want you to be familiar with, data. It's the most important thing that we have. It's the most valuable thing that we have. The biggest companies in the world are all data companies. Apple and Microsoft and Amazon and Google and Facebook and Tesla, they're all data companies. The things that you're willing to pay money for and that you think are so cool and interesting that you'll pay a little bit more for is largely because of data. Data allows it to do the things that we're oftentimes willing to pay for, or that just changes the way we work or anything else that we do. So let's look at that. The best data, you guys, has three qualities. Okay, and this is how I think of it: clean, coverage, and complete. Again, I'll show you my mental model, how I see this. So here we have some structured data, let's say. So when I say the best data has three qualities, clean is this. Here we have some column. You know what this is because you live in the world. Male, female, you know what that problem is. The machine doesn't. Machine's going to see three different things here. Okay, so your job is to say what you mean. Tell the machine what you mean. Same thing here. You can't have missing data. If you have missing data, you need to drop this row or you need to replace with something reasonable. And then what does this mean? It looks like everything here is 1, 2, or 3. Or was this a 1 and you tried to delete it and change it to a 3? Does this mean 1 and 3? Or does 13 mean something totally different? Say what you mean. You're trying to tell the machine the truth about the world. That's the only reason the machine needs you. Okay, or things like this. That's the first thing. That's clean. The next thing when I think of coverage, again, my mental model is depth. How many examples do you have? Now, not just quantity, but quantity and variety. Don't give me a bunch of images of a cat on a white couch. The machine might think that it has to be on a white couch to be a cat. Give it images of cats walking away where you don't see its face. The machine can say, oh, you don't see a face for it to be a cat. Or hiding underneath a pillow where I just see its tail. Or walking across the street at night where it's dark and I just see a silhouette. They're all cats. Remember what I said? If I can tell it's a cat, the machine has to be able to tell it's a cat. So quantity and variety of examples. Okay, that's coverage. And lastly, when I think of complete, I think of breadth. Not that you have to have more features, but each one of these is telling the machine something about the world. Is there something else I could be telling the machine that would help it solve the problem? Okay, if you don't give it to the machine as a feature, then the machine assumes that it doesn't exist in the world. If gender is important to your problem, you need to tell the machine about gender. Machine can't assume or deduce or infer or guess. The machine can't do any of that. It only knows what you tell it about the world. That's the breadth. Is there something else I could be telling the machine about the world? Is there some information I use, given that I live in the world? Is there some information that I use that the machine doesn't know? And that's your job here. That's what I think of complete. Okay? And so if machine learning, guys, is a rocket engine, data is the fuel. It's the most important thing that we have. Whoever has the most data wins. I'd rather have more data than the sexiest algorithm. It's data. In fact, I don't even say data usually when I'm working with you. I say examples. Whoever has the most examples wins, if that helps you. Okay, so let me give you an example of this to show you why data is so important. So let me show you what I mean by learning the relationship really quick here. So here we have some data. Let's say your big brain is the machine learning model for some company. This is their data. Just think to yourself, what's the function? Think to yourself, what is the function? What would solve that problem? What's the function? Okay, the function for this is 2x. So it is. The machine says, you give me x, I'll give you y. It's 2x. And the company's happy. Ooh, our models are doing really well. That's good. Here's a different company. Think to yourself, what's the function? What solves that problem? Well, for that company, it's x squared. They're happy. They say, oh, you guys, great job. 96, you guys go home early. This model is doing so well on our data. Then there's a third company, and you're the machine learning model for that company. And on their data, the solution happens to be x squared plus 1. So each of these companies is delighted with the model, how it's performing on their data. 96% accurate in-house. But you know what happens when they put it out in the world? Maybe 65, 70% accurate because they don't have enough data to reflect the whole world. But what about the company, guys, that has all the data? See if you can see the master function. It's a little tricky. See if you can see it. If not, I'll tell you in just a second here. About another 7 seconds. See if you can see it. So here's the master function, you guys. If it's even, it's x squared. If it's odd, it's x squared plus 1. This is the modulus operator, and it says if 2 goes into a number, what's the remainder? If it's an even number, the remainder is 0, so it's x squared. If it's an odd number, the remainder is 1, so it's x squared plus 1. This is the master function. This is the company who's always right because they have all the data. You might say, how are they so good at that? We can't even approach that, and that's because they have more data. And so the point is, by them having all of the data, it's the only way they can learn this function. Each company was right on the data that they had. But it's the company that has all the data that can learn this function that is right on all of it. So keep that in mind. The first thing you want to do is get as much data as you can, more than anything else. Okay? Now let's talk about model training. First thing is you. This is you, data. Remember, that's your job. And then you'll have some algorithm here. You and the machine work together. You're co-equals. The machine's your colleague. You're equals. There's things the machine can't do that you can do. There's things you can do that you do the machine can't do. You two will work together to form a model. And this model initially doesn't know anything about the world, so it makes random predictions. But you're smart enough to give it an answer key. That's supervised learning. Then the machine can look and say, ooh, oh, I get it. Okay. I did not think you'd like this song. I didn't think you'd like this song. Man, I sure thought you would love that song. It's going to go back and change its internal parameter and do it over and over and over. It's just an optimization problem for the machine. The machine doesn't know it's learning. The machine's just trying to be a little less wrong each time. Okay? And before you know it, the machine can say, ooh, I think I got it. I think I see it. I think I totally get your problem. There's your solution. The machine will solve it for you. As you give it examples and supervise its learning, we then call that a trained model. And that's what everyone's chasing when they say a model's trained. It's just it learns the pattern and the examples that you gave it. It says, I think I totally get, the kind of, shoes that you like or whatever it is if you're shopping or whatever it might be. Okay. Now let's talk about how we evaluate the model. We almost never use all the data, you guys. We'll talk more about this as we go. We usually split the data into a training and test set, maybe a 70, 30, 80, 20 split. Okay, and this is what the model's going to see over and over and over. So it's going to see this a bunch of times. We don't know if it's generalizing its understanding or if it's memorizing these. The machine can start to memorize these. Okay, for example, I think of it this way. The only way I can know if the machine truly knows the answer is to hold out some data it's never seen before. Let's say if it's image recognition. I'll say, machine, I can't give you every image of me. You have to generalize what I look like. You know, I might have a hat on tomorrow, shades on tomorrow. I might grow a beard. I might gain weight. I might lose weight. I might not have my makeup on, whatever it might be. The machine has to learn, generalize what I look like. That's what the machine's job is. And that's what this is right here. The only way we can know if the machine does that is to hold out some data. And so it gets one shot with this test set. If it doesn't do well, we shuffle the data and start over. So we get that test set out of the way. You give it a bunch of images to train on, adjust itself, makes predictions, adjust its parameters, make predictions until it minimizes its error. Then it feels really good. Now we feel good about this, maybe 95% accurate. Now we cross our fingers, go give it that test set. If it does well on the test set, then we can put that thing out in the world. Okay, it knows some things. That's what we do. So this is you. This is the machine. You two work together to form a model. And now we trust that model. I don't know who's going to walk in the door tomorrow, but when I get new data, I trust that the machine can tell me a little bit about the future. Okay? So just a few more things. I want to leave a little time at the end. So just a few more things I want to share with you guys. Let me give you an example, just the use of machine learning. Let's say that you have an e-commerce site and you have people coming to your site, but they're abandoning their cart for some reason. You see people are putting things in their cart, but you have a lot of people who are abandoning it. They're not finishing through. They put things in their site, then they leave and they don't finish purchasing. So you want to know what's going on. So you decide you want to offer them chat. Can't offer chat to everybody. So you decide you only want to offer chat to those who are more likely to buy than not, what we call high propensity buyers. Okay, high probability of buying, at least 50% chance of buying. Some people are there, they're not interested in buying from you. They just want to see if you offer it or what it costs or whatever. So you want to find people who are more likely to buy than not and only offer them chat and kind of help escort them through the sales process. Maybe they're not sure about your shipping policy or the return policy or whatever it might be. So the first thing we do, we get what we call a customer 360 or a user 360, as much information as we can. We'll have demographic information, age, gender, employment, whatever it might be. And maybe we'll have their behavior. What have they done? Have they been to the website? Have they interacted with your sales team? Have they responded to an email? You know, when you download some PDF or something from an email, that's a data point on you. So we're trying to get as much data as we can about a person. This might be data that you've collected or purchased on someone. This might be their behavior if they visited the site, bought from you, responded to emails. Now, once we take that data, this is what's important. This is what's going on in your site in real time. Okay, so I want you to see this. Look, this person clicked on a product, they viewed a summary, they checked a review, and then they bought from you. This person right here clicked on a product, they clicked a similar product, they compared products, but they didn't buy. You want the machine, you want to say, machine, can you see it? Can you tell when someone's going to buy from you? Pareidolia. Can you see the pattern? That's what you want machine learning to do for you. Okay. So here you're going to get all that demographic information and their behavior. And we're going to use machine learning to create what I'm calling a propensity model. You call it whatever you want. It's just a model. I'm calling it the propensity. It's the propensity of the probability that someone will buy from me. And we're just going to use, we're just going to feed that data and let the machine learn it. It's not you. The machine's going to learn it. And then the machine might learn, hey, if someone clicks on a product, maybe there's a 10% chance they buy. If they view a summary, maybe it goes up to 20%. They click something similar, maybe it goes up to 25%, et cetera. And so you have a bunch of people on your site, and in real time, you have propensity scores on them. And you can go up or down depending on what they do next, but that's what we want machines to learn. So for example, if you deploy that model, it's just waiting for someone to come. And when someone comes in, might say, you know what, there's a 3% chance that someone will buy if they're on your site. If they click on a product, ooh, it goes up to 9%. If they click something similar, it goes up to 27%. If they check reviews, ooh, now they're shopping. It's crossed your 50% threshold. You can now pop up chat. Tell them about your free shipping, your buy one, get one free, clarify sizing or your return policy, but you can kind of help escort them through the sales process. Okay, that's structured data. Let me just really quick talk about unstructured data, and then we'll wind down here. Again, I want to tell you my mental model. I just want to share with you guys. It just helps me. So again, I think it's so important to have a mental model so you're not stuck on jargon and just using jargon in terms. That's kind of a crutch if you can't see it or say it simply, you don't know it well enough, and that's okay. That's usually the test I will use. Can I see it simply and say it simply? So for example, I think of how a child learns. If you ask a small child, 3 or 4 years old, what a cat is, The child will think of it, whatever its cat is what a cat is. It's small, it's white, and maybe it's mine. That's all the child knows. And then as the child goes on in life, say, oh, it doesn't have to be small. It doesn't have to be mine. And then they'll say, oh, it doesn't have to be white. That's how a child learns. You're not telling the child everything. And so that's how I think of a machine learning model. When we're training a machine learning model, we're going to give it a bunch of positive examples. Say, machine, this is the thing I want you to learn. I will give it negative examples. These aren't those things, and let the machine figure it out. It's not you. Your job is examples. Then the machine will say, oh, okay, I think I got it. We call that a classifier. And now you're going to give it some image. The machine will say, oh, yeah, that's a cat. The machines think in terms of numbers. So maybe I'll put a 1 for a cat and maybe 0 if it's a dog. Okay, so that's typically what we're doing. I want to demystify this. You don't think it's math and coding. I want you to get a sense of this. So lastly, here's what I want you to understand. When we're training a model, especially with unstructured data, which we're going to talk more about next time, I think of, here's how I think of it. I think of us as teaching the machine what a cat isn't. I don't know if you can understand that. That's how I think of it when we're doing unstructured data. Whether it's you, I want to learn what I'm not. And let me show you what I mean by that. Here we have a cat. You live in the world. You know this is a cat. Machine doesn't know that's a cat. Machine doesn't know if this thing right here is a cat or if this right here is a cat. Machine doesn't have a clue what a cat is. So I think of it as giving the machine a bunch of images, and the machine gets to play like 10,000 questions with you. It can ask you as many questions as it wants to try to figure out what a cat is. So the machine might say, oh, okay, is it the fact that it's outside that makes it a cat? You might say, nope, it doesn't have to be outside. The machine might say, well, is it being alone? Is that what makes it a cat? Nope, it doesn't have to be alone. Is it these eyes? Is it the eyes that make it a cat? Nope, it's still a cat if you can't see the eyes. Is it the pointed ears that make it a cat? No, cats don't have to have pointed ears. Is it the color? Is it being gray that makes it a cat? No, cats can be all kinds of colors. Is it the size? Is it kind of being smallish? Is that what makes it a cat? Nope. Is it the fact that it's maybe facing in a different direction or big and fluffy? Are any of those things related? Nope. Cats can be facing in any direction. They don't have to have any hair at all. And what's left is cat. That's how I think of it when we're training unstructured data. I want to give it as many examples as I can, so whatever's left is its solution once it's gone through all of my images. Whatever's left is cat. I can't tell you what a cat is, but I can give you a bunch of examples. And that's how I think of it. So just so you know, quantity and variety of examples helps the machine do that. Okay. So last thing here, let's just walk through that process. First thing is getting as much data as you can. Is it labeled? Supervised learning. Okay, get as much data as you can and hope you have an answer key. The next thing is, if it's structured data, tell about the world. Is it complete? Have you told as much as you can about the world? Is there anything else that you haven't told it about? Is it clean? Have you said what you mean? Have you told the machine the truth about the world? And do you have coverage, quantity, and variety of examples? The next thing is some algorithm. Machine learning is not you. You're going to now hand over your beautiful data to the machine. Say, machine, I'm going to go take my nap now, or I'm going to go to lunch. I'll be back in a little bit. Here's the data. It's the machine's turn. Remember, you and the machine are working together. Machine learning is not you. You've done your job and give it over to the machine. You'll choose some algorithm, perhaps, but then the machine says, just get out of my way. Okay. After that, what level of performance is sufficient? That's subjective. Think about it. What keeps you paying if you have a subscription for movies or music? It doesn't have to be perfect. Is it 30%, 50%, 70%? I don't know. I'm sure they know internally, but it doesn't have to be perfect most of the time. Now, for some medical use cases, it might have to be 95 to 99% accurate to be useful, but you're going to have to determine that. Then lastly, you put it out in the world. The point is, machine learning is as much art as it is science. Okay, each of you would make a different choice for all of these. I just want you to be aware of that. It's art. There's a lot of you uniquely in this. Your worldview, how you understand your problem, your domain knowledge, your creativity, your understanding of your data set and your domain. Okay. Then lastly, why machine learning now? I want to leave you guys with this. Why machine learning now? Why is it such a thing in the world? Everyone's familiar with machine learning. That wasn't the case maybe less than 10 years ago. And part of it, you guys, the increasing availability of data. You go back, say, 10 plus years, with the proliferation of the internet, all that data that we have that we didn't have before. As you guys know, machines learn from data, from examples. 20 years of social networking, who you interact with, what you watch, what you like. And then the biggest thing to me is this 10 plus years with mobile computing. It's changed everything because we carry it with us. Smartphones. If you want to know something about a person, look at his or her phone. Man, you give me just 3 minutes with your phone. Just give me 3 minutes with your phone. I'll tell you so much about you. And that's the big thing, is how much data that we have. The other thing is the sophistication of these algorithms. The quality of these algorithms, you guys, has accelerated. You guys heard of GPT-3 and GPT-4, ChatGPT. We couldn't have done these things even a few years ago. And the reason that is because of the increasing availability of computing hardware and software. Your phone is probably more powerful than a desktop computer was 10 years ago. And if you're familiar with cloud computing, we have virtually infinite storage and infinite compute. We couldn't have trained these models a few years ago. And the other things, tools like TensorFlow, if you're familiar with these libraries for deep learning and AI, they've only been available publicly for developers or people to use maybe the last 5 years or so. So it's just an imperative technology. So the last thing I want to leave you guys with is this. How do machines learn? Just think to yourself. See if you can say it in 2 words. No jargon to a non-technical person. Just think to yourself, how would you explain to someone that, how do machines learn? And the last thing I want to leave you guys is this. Machines learn by example. Okay, if you can get examples of your problem, you can do machine learning. And that's what I'm leave you with as we go into next time with more AI and deep learning and unstructured data with images and language, that machines learn by example. You're going to hear us talk a lot about that, is just collecting examples of your problem. Okay, so next time we'll talk really about unstructured data with images, more specifically to AI, which is more deep learning. From now on, it'll be all deep learning. This is more kind of a combination of two, but that's where we'll be going next time. And I know we're short on time, so Christelle, let me hand it back over to you, and we will move forward here. So thanks, you guys.
Absolutely. Thank you very much, Professor Anthony Ross. So something that I didn't say was that Professor Anthony Ross was my first AI teacher ever. So it was very important for me, for him to be, as a data scientist, to be providing the technical knowledge to all of you. So thank you very much, Professor Anthony. I always love learning and listening to your classes and the way you simplify all the different contexts and concepts. So again, learning is going to continue. I definitely would love to allow a little bit more time. Maybe we have 6 minutes left. So if anyone has a question, please raise your hands. You can either unmute yourself or put your question in the chat. Otherwise, as I said earlier, let me share my screen with you. There are some additional learnings and books that myself and Professor Anthony Ross are ready for you to continue the learning. The next class is going to be in the end of April. So in the meantime, again, I am part of Cisco Systems. This is the company I'm working for, and we have this amazing Cisco Networking Academy program where we are also offering Introduction to Data Science free classes with a certificate of achievement at the end of the 6 hours that you're going to spend. So the link is here. I also wanted to share 2 links of classes that I took very recently on artificial intelligence. 2 of them are on Coursera. You have the link here as well, and the information will be shared with you, or you can take a screenshot. So AI for everyone, and some additional specializations classes in machine learning introduction. Professor Anthony Ross, when I took his class 2 years ago, almost, I believe, I know Professor recommended some additional books for beginner and intermediate who are interested in artificial intelligence and machine learning. So you have the list of the books here. And myself really working more around AI for businesses and how we can innovate responsibly within our companies. Those are the books that I recommend. I have recently read Competing in the Age of AI. I'm completing my learning as well. So take advantage of the books which are available for you to further your learning, deepen your learning, and make sure that you are becoming the AI expert to be part of the transformation, which has already started and which is going to accelerate within the next few months and years. Thank you very much, everyone, again. And we look forward to seeing you next month for the next class in AI for understanding images. And let me just take a look at the chat before I stop to see if there is any question. No questions? No questions from everyone? Oh, you are completely new to AI and you enjoyed the class. I'm glad. And again, one of my most favorite concepts from Professor Anthony Ross are machine learns by example. So when we talk about machine learning, and I am not a data scientist, I am not an engineer, I've studied economics and business, but because I know how AI is accelerating and contributing to the transformation of the world we live in, it is something that we have to learn. So machine learns by example. one of my favorite quotes from Professor Anthony Ross. The second one is, machine is not in the world. You have to tell the machine about the world. So we can, by being part of AI and machine learning transformation, we can decide the type of data we want to put in front of the machine to learn about us, to make sure that we are part of the transformation, to make sure that there will be Black people in the future. Because again, the main two powers who are going to accelerate the pace and the race in AI are China and North America. So if we want to be part of the conversation, we need to make sure that our data are also going to be trained, part of the training models for the development of artificial intelligence technologies. And last but not least, thank you very much, Professor Quote. I took one last quote. Machine learning is as much art as it is science. Beautiful. I love it. All right, Mbali, I don't know if you wanted to say something to close the class.
Thank you so much. I've just unmuted myself. Thank you so much to everyone who has attended our class. I see there is a last question that maybe Christelle or Professor Anthony, you'd like to answer in the next session, which is, what are the sets of skills that one needs to have to succeed in AI? So I'm not sure if we have, I'm looking at our time and I know that we are out of time. So perhaps maybe this is a question that we can look at, or maybe start our next session with. Thank you so much to everyone who was part of our first session of becoming an AI expert. We will be sharing our live recording session from today. We will send out an email to everybody, and we definitely hope that we have more of you joining in our next session. Again, as I had previously mentioned, we have over 40 people who have registered for our classes today. So we just want to encourage you guys to please just ensure attendance in our next session so that Professor Anthony and Christelle continue to bring us these amazing classes. Thank you very much again.
Thank you, everyone.
Everyone, see you guys again.
Thank you, Professor.